All righty, so the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Welcome to Tuesday morning. Today, eventually, we're going to go to section 8.3, but first I have some questions that were emailed to me. And so this is from section 8.2, part 2, starting with problem number 7. Can you see problem number 7 from WebAssign on your screen? Somebody just let me know that I have in fact pushed the right buttons. Anybody?
Yeah, I can see it.
Thank you. Okay, so number 7 says, write an equation for a linear function whose graph has the given characteristics. It passes through the points -2, 1 and 2, -5. So we need to find the slope. I'm going to call this point 1 and this point 2. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is -5, y sub 1 is 1, x sub 2 is 2, and x sub 1 is -2. -5 minus 1 is -6. 2 minus -2 is 2 plus 2 is 4, which reduces down to -3/2. So the slope is -3/2. Any questions about how I found that? All right. So using y equals mx plus b, the slope is going to go right there. So y equals -3/2 x plus b. Then we'll take either one of the points. I'm going to go ahead and use point 1. So x is -2 and y is 1. So 1 equals -3/2 times -2 plus b. -2 over 2 reduces to -1 over 1. So 1 equals what? -3 times -1 is 3 plus b. Then if we take that and we subtract 3 from both sides, we get b is -2. So y equals -3/2 x minus 2, or f of x equals -3/2 x minus 2. And there is our first answer. Again, any questions about that? All right. This takes us to problem number 12. The volume V of R of a gasoline storage tank in cubic feet is given by the polynomial function V of R equals 4.2 R cubed plus 37.7 R squared, where R is the radius in feet of the cylindrical part of the tank. What is the capacity of the tank shown if its radius is 4 feet? So basically R is 4 feet. So we want to find V of 4. So we'll have 4.2 times R cubed plus 37.7 times R squared. So it's calculator time. 4.2 times R cubed plus 37.7 times R squared. And I come up with 872, and that would be cubic feet. So there's the answer to that first question. Any questions there? Okay, now we're going to take a look at number 13. Similar idea. A software company has found that on Mondays, the polynomial function C of t equals -0.0625 t to the 4th power plus t cubed minus 6t squared plus 16t approximates the number of callers to its hotline at any one time. Here, T represents the time in hours since the hotline opened at 8 a.m. How many service technicians should be on duty on Mondays at noon if the company doesn't want any callers to the hotline waiting to be helped by a technician? Okay, so T is time, the number of hours since 8 a.m. At noon, we're talking what, 12 p.m., which is, let's see, how far is it from 8 a.m. to 12 p.m.? That would be what, 4 hours? So we want to find C of 4, which is negative 0.0625 times 4 to the 4th power plus 4 to the 3rd power minus 6 times 4 squared plus 16 times 4. Okay. Negative 0.0625 times 4 to the 4th power plus 4 to the 3rd power minus 6 times 4 squared plus 16 times 4. And it says, it doesn't say anything about rounding. Anyway, C of 4 equals 16, so 16 technicians. Does anybody need any help with calculator instruction on this problem? Okay, so this was what, number 13. And finally, let's take a look at number 14. A rectangular sheet of metal will be used to make a rain gutter by bending up its sides as shown below. If the ends are covered, the capacity f of x of the gutter, in other words, how much it will hold, is the polynomial function of x. F of x equals negative 240x squared plus 1440x. Find the capacity of the gutter if x is 5 inches. So we want to find f of 5. So negative 240 times 5 squared plus 1,440 times 5. Again, we go to the calculator. Negative 240 times 5 squared plus 1440 times 5. And we get 1,200 cubic inches as our final answer. Okay, that takes care of the questions that people emailed me. Any questions from you folks before we go on? Ready? I am going to switch screens here. So give me a minute. And now let's see here. Okay. So now you should see a screen that says 17a f of negative 2. Everybody see that? Somebody tell me.
Yeah,
Yeah.
I see it.
Thank you. Okay, just wanted to make sure. Like I said, I've gone on for 10 minutes with the wrong screen on until somebody would say, wait a minute, we can't see what's going on. So, all right. So what we're going to do now is we're going to deal with function notation and look at values on the graph and interpret and find them and all of that. Okay, so this problem says, basically, they want us to find f of negative 2. So over on the right side, we have the graph of f, okay? F of negative 2 is kind of like, let's see here. it's like saying, oh, it's not letting me do that. Hang on. Here we go. It's like saying, complete this ordered pair, -2, comma, whatever. Okay. Hopefully my pen isn't going to give me issues. Oh, well. Okay. So what do I need to do? I need to look at the graph over here. And where is x equal to -2? Right there. Okay. So what's the corresponding y value? Right there. What is it?
Is it -4?
Yep, it is. So if we completed the ordered pair, it'd be -2, -4. But in function notation, f of -2 equals -4, right? Everybody okay with that?
Yeah.
All right. New question, f of 0. So we come over to our graph and we say, when x is 0, what is y? Or it's like completing the following ordered pair.
Wouldn't it be 0?
It would be 0, correct. So f of 0 equals 0. Any questions about that? So those first two questions were basically given x, find y, given x, find y, but it was written as function notation. Now, this next example says the value of x for which f of x equals 4. So now what they want us to do is complete that ordered pair. So what is x when y equals 4? Well, y equals 4 is right about there, isn't it? So what's the corresponding x value?
2.
2. Every once in a while, this thing goes crazy. I tested it earlier. It was working fine, but now it's not. And the only way to fix it is to reboot it, which I'm not going to do. So we'll just hang in there and hope for the best. Some kind of a, anyway, that's a sad looking 2, isn't it? All right. Next question, the value of x for which f of x is -2. So now we want to know when y is -2. When y is -2, that would be what right here? What's x?
-1.
Right. So, and I'm just writing the ordered pairs to show you the equivalent in regular notation. So go ahead.
I'm a little confused when we're plotting the y's.
Okay.
So like how one of them was 4. I was thinking of just going to exactly 4, but then in my head I'm like, well, then is x 0?
Okay, now you say exactly 4. Is that an x value or a y value that's exactly 4?
Y value?
Okay, y is 4 right here, but that's not on the graph. Where is y equal to 4 on the graph when x is 2? So you can't just find y equals 4 randomly. It's got to be where on the graph is there a point that y is 4.
Oh, okay.
Does that make sense?
Yeah.
Okay. Any other questions on this problem? New problem, same idea, only now the function is s. So s of -3 equals what? Well, let's see. Where is the input, the x value, -3? Wouldn't that be right there? So aren't we looking at that point. So what's the corresponding y value?
2.
Right. Okay. Questions there? S of 3 equals what? So now, where on this graph is the input equal to 3? Right there. What's the corresponding y value?
4.
4. Excellent. Okay. Now, it says the values of x for which s of x is 0. On the previous problem, it said the value. So now, apparently, we've got more than one x value leading to 0 as a y value. So s of x or y equals 0 would be right, what, there, and there, and there, wouldn't it? Aren't there 3 x values that have a y value of 0? So x equals, what's the first one going from left to right?
-1,
And then,
1,
and finally,
5.
yeah. And again, my apologies for the sloppy writing. It really isn't me. This thing acts weird. I don't know why, but like I said, I tested it earlier and it was fine, but not anymore. But that's supposed to be a 5. Oh, well, anyway, okay. Next question, the values of x for which s of x is 3. So where is s of x equal to 3? Right there and right there. What's the x value for that first point?
2,
And the second point?
4.
Right. Now, wait a minute. We've got 2 different x values going to the same y value, and I'm using function notation. Can that work in a function? Can you have 2 inputs going to the same output? Yes, you can. You just can't have one input, going to more than one output. So these are okay as functions. Any questions about this problem?
I have a question.
Yes.
So I'm getting confused with like the S and then the number and then the S and the letter. So if it is like S of -3, they're giving us the Y value and we're looking for the X value.
No, you've got that backwards. Okay, let's go back to this. Okay. This number is replacing X. So it is X. So when we're given f of -2, it's saying if X, the input is -2, notice the input is on the inside. What is the output? Okay. So here, given X, find Y, given X, find Y. Down here, they're saying Y equals 4. Find out what goes inside as the input to find the output.
But they're already giving us the output, right?
Yes.
And the input.
Yes. The input is X, the output is Y. The input is on the inside. The output is on the outside.
Okay, I was confused about that
Okay.
too, between the f of x and the f of s or whatever.
That's what they
So
pay me the big.
whatever letter it is, it's always times by X. There,
Whoa,
so
whoa, whoa,
f
whoa,
of
whoa.
X is always
There's no
X.
times going on here. It's not multiplication.
Well,
Whatever.
so whatever's inside of the parentheses, whatever.
Yes.
So that's always X, whether it's a number or X, right?
Yes. It's the input.
Okay.
Now,
All right.
this just says that we're dealing with a function f, whereas here, s, we're dealing with the function s.
Okay.
We okay?
Yeah, it's just I
I
was
know it's
getting
confusing.
confused from that.
That's what they pay me the big bucks for, is to confuse all of you. Have I accomplished my goal?
Yes.
All right, hang in there. We got more examples. Oh, here we go. Same thing again. So g of -2 is saying when the input is -2, what is the output? So basically, that question is the same thing as saying, complete this ordered pair. Okay? That's supposed to be a -2 inside of there. So where on this graph is there an x value of -2? Oh, there's x equals -2. So what's the y value there?
2.
2.
-2.
Y. Not as in WHY, but as in the y value. What is the y value right there?
2.
+2. The x value is -2. The y value is +2. Okay? You getting that? Remember, the x values are along this line, the y values are along that line. So g of 0, when x is 0, what's y?
+2.
Correct. Thinking maybe if I go slowly, it will work better. So it's like they're asking us to complete these ordered pairs. Then it says the value of x for which g of x, which is another name for y equals 3. So they want us to complete this ordered pair. Where is y equal to 3? Right there. What's the corresponding x value? Right there. What is it?
-1.
Good. Okay. So all we're doing here is saying, given x, find y, given y, find x. But it's function notation, and you got to get used to the notation. Okay. Functions aren't going away. Sorry. All right. The values of x for which g of x is -1. So where is g of x equal to -1? Well, right there and right there. So what are the values of x for those 2 points?
-3 and 2, or 1. Is it 1?
Yeah, -3 and 1. Okay, let's see if I can get my pen to cooperate. -3 and 1. Okay. Any questions there? You good? All right, more of the same. Oh, find the domain and range of f. Now, on this graph, because there's an arrow here and an arrow there, it means this thing continues on, this thing continues on. So the domain is all the x values. If this thing keeps going on, going down to the left as it goes down, and this thing keeps going up, but going to the right as it goes up, what's the domain? What x values would be included on that graph?
+1 and -1.
And okay, I was thinking that, but I thought they wanted numbers.
Those are numbers. Those are all real numbers. You're assuming that it stops here, but it doesn't stop. Find the domain, all of the domain. So basically, if I drew that line, which goes on forever in both directions, and I came back and said, okay, let's pick out each individual point on that line. What values of x would there be? Well, let's see. X is 0, 1, 2, 3. Oh, x is 0.5, 0.7, 0.23841. It just, all the x values, they go on from -infinity to +infinity. Can you see that?
I thought at your first little arrows on the inside that you had a break right there.
Here?
Yeah,
No breaks. Let's see here. Let me. Oops. Okay. You're thinking there's a break there?
yeah. So now that you took everything away, not, so you would have, the range would be infinity to infinity on both of them.
Negative infinity to infinity. Yes. So the domain and the range would both be all real numbers, which using interval notation looks sadly like that. Okay. Everybody getting that? Okay. Domain and range of this. So what X values are included on the graph? And again, it doesn't stop there. That arrow implies it keeps going up and over. It keeps going up and over. So what X values would be included in the domain? Let me ask you this. Is -5 an X value that's included?
Yes.
What?
Yes.
Yeah, because doesn't this graph continue on? So like here. How about -1,000? Would that be included?
Yes.
-3 gazillion.
Yes.
How about +42.8?
Yes.
What's the domain?
Negative and well, the infinity sign. I don't know if that's the right word
Yeah,
for it.
negative infinity
And infinity.
to positive
of-
infinity.
Yeah.
Okay, now be careful. What's the range? For you old folks out there, it's the backup band for Bruce Hornsby. Remember Bruce Hornsby in The Range? Nobody remembers. And we're not talking about that stove in your kitchen. We're talking about the Y values.
+3 and higher.
Bingo.
Where did you find that answer? I'm lost.
Right there. What's the lowest Y value on the graph? 3.
And where does the infinite sign come from?
Okay, so Y = 3 is included there. Y
Mhm.
= 4, 5, 6, etc. This keeps going up. So as it keeps going up, Y keeps going up, but there's no stopping it.
Oh, okay.
All right. You seeing it?
Yeah.
Okay. This is tough stuff. You folks are doing fine. You got to struggle with it, I know. All right. Next one. Find the domain in the range. Careful. What's the domain?
0 to positive infinity. And then the range is negative to infinity.
I'm not really
-2.
grasping this part.
Say that again.
I'm not really grasping this part of the lesson.
Okay. All right. Look at the graph. If I said list all of the X values that you see as coordinates of that graph, okay? Is there a point on that graph that has an X value of 0?
Yes.
Is there a point in that graph that has an X value of 4?
Yes.
Is there a point in that graph that has an X value of 0.001?
No.
Wouldn't that be right about here?
Oh.
This is a continuous line. So every X value from X is 0 to X is 4 is included there. You could pick any number between 0 and 4, a big long decimal number, 3.7982143, whatever, and there would be an X value corresponding to that. Are you seeing that?
Not kind of.
Not kind of?
Not really, kind of.
Okay,
So why isn't it 0 and 4 instead of 0 and infinity?
because it doesn't stop at 4. X is 6 is right there. There's an X value that is 6, that point that's on the graph. This graph continues on to the right as well as going down. So let's see, 5, 6, 7, 8. Here's 10. The coordinates of that point are 10 comma something. So X is 10 is included.
Okay.
You got to think beyond the picture because the arrow says it goes on to the right forever. Is that making any sense?
A
What I
little
do
more.
for this section
What's
is I
that?
take the, what I do for this section is I take the graph and split it into the 4 quadrants. And like the top left is a negative X and a positive Y. And then
Yeah.
go on and so forth. And so
Sure.
it's easier to figure out what the domain is equal to in that quadrant if it's a single line like that. So the domain could only be a negative of an X or a positive of a Y, if that helps.
Except that what you finally said at the end was just backwards. Wait, you said, yeah, you said, so what happens to happen here is a negative X and a positive Y, and this is a positive X and a negative Y.
Yeah, sorry. But if you do the coordinates like that,
Yeah, I understand what you're saying. Yeah.
like that.
I
then
don't know
it
if that helps or just adds to the confusion. It just depends on each person. But in this what she's saying is in this quadrant, the X values are positive, aren't they?
Yes.
And the Y values are negative.
Mhm.
But it starts at 0. So the domain, the X values go from 0 to
Oh.
infinity.
Okay.
All right. But the Y values go from 0 to negative infinity, but we don't list it in that order. We list it from smallest to largest.
Okay. That makes sense. I kind of understand what she said now. That makes
Okay,
sense
awesome.
more.
I don't care how you get it as long as you get it. So good job, Lindsay. Okay.
Thank you.
You're
I'll-
welcome. I
When
have to have,
I get my paycheck, I'll send you a picture of it there. Okay. Which I actually never see anyway. Okay, so it says find. So now what we're going to do is we're actually going to put the two kinds of problems together. The first ones were given X, find Y, given Y, find X, and then it said find the domain and range. Now we're going to do all of that with a single graph. Okay. So f of 1 is saying when X is 1, what is Y? Oh, but be careful because our scale has changed. On the x-axis, each square is 1 unit, but on the y-axis, each square is 5 units. So be very careful, okay? So f of 1, when x is 1, what's y?
5. Is it 4, 3?
Look at the scale. What's each square on the y-axis?
Is it 15?
Yes, each square is 5 units, so 5, 10, 15. Details, details, okay? Everybody all right with this?
Yeah.
All right, f of -3. Well, where is x -3? Right there. What's y?
5.
Good. It's like it'll let me make straight lines, but it doesn't like it when I try to make curved lines. Okay, now the values of x for which f of x equals 0, which is another way of saying the values of x for which y equals 0. Where does y equal 0? On the x-intercepts. So there, and there, and there. So x equals what?
-4 and -2 and 0.
It just does not like me making twos. X is 0. Yeah, I've had this problem before when I didn't have all the graphs drawn ahead of time. It was a disaster. It still is a disaster, but it's livable. Okay, good so far?
Mhm.
What's the domain? Those arrows mean it continues on. So this thing is going up, but it's also going slightly to the right as it goes on. This thing is going down, but it's also going slightly to the left. So as it keeps going forever and ever, what's the domain?
An infinity sign?
Where do you start?
0.
No. What's the
Say a
smallest?
negative affinity.
Negative infinity, right. You always go from smallest to largest. The smallest domain value is negative infinity. The largest is positive infinity because it goes from here to there, everything in between.
So is the range the y value then?
Yes.
Okay.
So what's
I
the
got-
range for this?
Negative, or is it 0 and infinity?
What about these values? Aren't those negative y values? It doesn't start at 0.
So negative infinity and infinity?
Mhm. So the domain and range are both all real numbers. You seeing that?
Yes.
Okay. Any questions, anybody, before we go on to another example? Here we go. Same thing again. G of 1. Okay, our scale here, every square is 1 unit, both directions. So G of 1 is what?
Is it 0?
No,
2.
2. Okay, where is x equal to 1? Right here. So that point has an x coordinate of 1. What's the corresponding y coordinate? 2. You seeing it?
Yeah.
Okay, what's G of -4?
-5.
Excellent. Everybody see that? Right
No.
there. Okay, right there. Isn't that the point? -4.
Oh, okay.
5?
Yeah. I didn't see the point for some reason.
The thing you got to get straight is, are we looking for x? Or are we looking for y? Do they give us x? Do they give us y? Here, they give us x. Oh, where on the graph is x -4? It's right there. Oh, what's the corresponding y value? -5. Okay. All right. The values of x for which g of x equals 4. What x values correspond to a y value of 4? Where does y equal 4?
Would it be 4 and 2?
Y equals 4 right here. So what are the corresponding x values?
-2 and 2?
There you go. Okay. What's the domain?
negative infinity.
To what?
I don't know, the top of it's kind of throwing me off on the top half.
You don't even need to be looking at the top half.
Oh,
What's the domain? What's happening right here?
it keeps going.
Which way?
Negative.
Which other way? It goes negative in terms of y. What is it doing in terms of x?
Positive.
How far?
Infinitely.
Seeing it?
Yeah.
The problem is, it's kind of like this, and this works well in a classroom, but maybe not here. I can't see what you're doing, so you'll just have to tell me the truth. Hold up this little finger. We're not going to play pull my finger. Hold up your pointer finger, okay? Everybody just do that, all right? Now,
Mhm.
I want you to touch your nose with it. Did anybody touch your ear?
No.
Anybody? Okay. Usually in a classroom, some people do. What's my point? Well, I said one thing, but I did another. And so your brain might have seen it. Oh, wait a minute. Well, this is kind of what's going on here. I'm asking you questions, but your brain is seeing things differently from the way I'm asking it. You're seeing this graph going down here. And so you're thinking, oh, it's negative. Yeah, the y values are negative, but the x values are still in quadrant 4. Let's 1, 2, yeah, 4. So the x values are positive. So as this thing goes down, it's still going to the right. As it goes down, it's still going to the left. So the domain is all real numbers. You seeing that?
Yeah.
Okay, now, what's the range? What's the smallest y value on the graph? And I don't mean just what you can see, but implied. What's the smallest y value?
Negative infinity to positive 5.
Almost. Look a little closer on the. It's not positive 5.
Oh, positive 4, sorry.
There you go. There you go. Good job. Because right here, that's the highest y value, as is that. So the highest y value is 4. The lowest y value is negative infinity. Some of you are getting better and better understanding, and I feel like some of you are just getting more and more confused.
I feel like I'm in the middle.
Middle. Okay. All right. Next one. Let's see here. Why don't I have anything written? Hang on. 72. Oh, okay. Here are the instructions. Determine whether each graph is the graph of a function. If it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. So is this the graph of a function? And if it's not, give evidence to show that it's not. All right, now, what do we know about functions? We know about functions this. For each input, there is exactly one output. So you can't have one x going to more than one y. But you can have several x's going to the same y. There's something called the vertical line test, okay? If I, let's see here, I still got red, yeah. If I were to draw vertical lines through the graph, is there at least one place where if I drew a vertical line, it would cut through the graph more than once? Absolutely, like there and there and there and there. Okay, tell you what, let's get more specific. Let's draw this line right there. That line goes through x equals 2. You see that? Or have I got too much going on there? Tell you what, let's go back. Let me do this. Oh, that's not what I wanted to do. Okay. Oh, it won't let me undo it. Doggone it. What I want to do is get rid of all the lines except. Anyway, let's draw a new one. Let's draw this one right here. That line goes through x equals 5. You see that? Everybody okay with that? Doesn't every point on that line has a coordinate, an x coordinate of 5? So here we have the point 5, comma 5. Down here we have the point 5, comma -5. Oh, we've got one input going to two different outputs. When x is 5, x goes to +5. When x is 5, x goes to -5. So this is not a function. It violates the vertical line test, is what we say. Let's look at another one. How about this? Is this a function? Now, the solid dot means the point's included. The open dot or the open circle means that that value right there is not included. It is included up here, but not down here. So does this graph pass the vertical line test? If I draw a series of vertical lines, is there any place where it's going to cut through the graph twice in the same line?
No, it passes.
Yeah, so this is a function. Now, if I came back and filled in even one of those circles, now it's not a function, right? Because it would have, when x is -2, y has two different values. How about this? Function or not?
No.
It's supposed to be a circle. It's not, because it fails the vertical line test all over the place. How about, like, let's see, for here, we've got what, the point 3, -2 and 3, -6. So no, not a function because of 3, -2 and 3, 3, -6. Okay. I mean, there are other values as well. I mean, shoot, there. It fails the vertical line test. For each x, there's more than one y. It's not a function. Okay. Well, that's all I've got for you today, as if that wasn't enough to keep you busy. So wrestle with this. I will be back this afternoon at 1:15, and I'll be back tomorrow with more fun with functions. So I'm going to go ahead and stop the recording.